We'll start at 5:35.
So yeah, I guess we'll start off with our lecture today then. So yeah, first I'll go by introducing myself. I am Anirudh, and today I'll be taking up the lecture on two of the most fundamental concepts that you would always need when if you want to dive inside data analysis and machine learning in your future. So those will be Numpy and Pandas. So we'll start off with Numpy. But so before starting about Numpy, do you know that Numpy and Pandas are basically libraries? And what is a Python library? A library is basically a collection of related modules which has a lot of bundles of code pre-written inside it, which basically like makes our life easier. It doesn't require us to keep writing that code again and again whenever we need to call that. We just have to call the name of that library and we are done. So that's what a Python library is. And one such library is NumPy. So now what does NumPy do? Before that, I'll just give a disclaimer. This presentation is not the entirety of NumPy. And NumPy is a very vast concept. And if you want to know everything about it, I suggest just click on this link in this code and you will just go to the official NumPy documentation and they will have everything that you need to know about it. But I'll just be covering all the fundamental concepts about NumPy today. So yeah, what exactly is NumPy? So imagine you have some sets of data and you want it to be in the form of an array. You want it to be ordered. So that's where NumPy will help you. NumPy is a library of Python that will help in analyzing the data. It's basically used in data science and it helps us to arrange all the data we have in an array as a list. So before starting off, let's just install NumPy first. Since we are using Google Colab, so we don't need to explicitly install it. But then if you're using some other software to run the code, I'll suggest you do this because this is what will install the library in your software. And yeah, so if you're using some other software, we would send off the documentation for that along as well. But for the time being, we'll just be doing all of this in Google Colab because that's pretty easy to do. So yeah, this is what we'll run to install NumPy, !pip install NumPy. And you can see that since it's already installed, we get a message saying requirement is already satisfied. So yeah, then we will go to what exactly are NumPy arrays. So arrays are of two types, and I'm pretty sure you might have come across both of these terms before. One is matrix, well, one is a matrix and the other is a vector. Now the difference between a matrix and a vector is a vector is strictly one-dimensional. It cannot have more than one dimension. It will be a continuous set of values, but it can never have rows and columns together. And whereas a matrix is an advanced form of a vector, I'll say, where you can store data in a set of rows and columns. Wait, the number of rows and columns depends on us. That's just the hyperparameter that we'll define whenever we are making a matrix. So yeah, once we are accustomed to what basically arrays are, we'll go off to how to create arrays. So before creating arrays, we first need to import the library. The library that we installed, we first need to import. We need to bring that into our code. So for that, we use import numpy as np. This as np that you see, that's basically just to make the word shorter. You don't want to write numpy every time you want to call the library, right? So if you just write that as np, you can always just write np dot and then the code, the software understands that you want the numpy library to be called and it does so for you. So yeah, so after this, let's just create an array, some random array, and with all random values in them. So for that, we'll start off with ARR, that's the name of the array that we want, is equal to np dot random dot rand 3, 3. Now 3, 3 is just the dimensions of the array that we want. And in this case, it's a matrix because we are defining the number of rows as well as the number of columns. Like I said, that's completely on us. So for example, yeah, so suppose we create a list. A list is basically just, you would definitely have learned what lists are in Python. So now to change that to an array, a numpy array, you have to first write the name of the array, whatever you want, is equal to np dot array list one, the one that we have made. This list will then get converted to a numpy array. So yeah, you can see how the output is here. It has been converted to an array. So now creating a list of lists and converting it into an array of 2 dimensions, like I said, a matrix. So let's just first make a list of lists. For example, you can see here, these purple brackets that you see are lists in themselves. They are lists of 3 values each, and they are encompassed within another list shown by the yellow brackets. So this is basically a network of lists, one inside the other. So now if we want to show this as a matrix, we just write np.array again and input list2 inside it, and then we will get the entire list as a form of a matrix. Now I have a question. How would you know how many dimensions this has? Like I said, matrix has 2 dimensions, a vector has 1 dimension, but how is it so? You get to know that by, this is a small trick for it. You get to know that by the number of brackets the first value has before it. That means here there are 2 square brackets before 11. Don't consider the parenthesis. I'm just talking about the square brackets. Since there are 2 here, that means our matrix is 2-dimensional. And here, since there is only 1 before 11, that means this is a 1-dimensional array. So yeah, after this, we'll go off to how to create numpy arrays using built-in methods. Built-in methods basically mean I can just input some function that's already given in the numpy library, and I can make a list or an array on my own. For example, suppose I want a continuous set of values with a constant step between them. Now, what do you mean by a step? A step is basically the difference between each consecutive number. For example, I want the numbers 0 to 10 with a step of 1. That means I want numbers 0, 1, 2, 3, 4, 5, 6, and so on. So to create an array like that, I'll just write np.arange. This is a function, and it starts from 0, ends at 10, and it has a step value of 1. So start, end, and step of 1. Here, the start is inclusive. The start value will be included in the array, and the end value is exclusive. The end value will not be included here. It will just go from 0 to 9. To create an array of all zeros, it's just np.zeros and the size of the array that we want. Since it is 5 here, we get an array with 5 values. We can also create a matrix like the same way by np.zeros 3, 2, where 3, 2 will be the number of rows and columns respectively. So we have 3 rows and we have 2 columns, and all of them are zeros, like expected. Then the same way, we can also create an array of only ones, that's np.ones with the size of the array, that's 5 ones, and we can also create a matrix the same way. I've just not done that here. Now to create an array where the values are spaced equally in an interval, this requires a different function altogether called np.linspace 1, 20, 5. Now this is a bit different from what we saw earlier, because here this 5 that we see is not the step value. This is the number of values that we want in our array. And here another thing is, for example, if I ask you to give me 5 numbers between 1 and 20, your intuitive guess would be 4, 8, 12, 16, and 20. But then that set, doesn't it start from 0? It goes from 0 to 4, 4 to 8, 8 to 12, and so on. But here we have to start from 1 and then go to 20. So basically we have to find 5 values in a span of 19, not 20. So hence we get values in the step of 4.75, that's 19 upon 5. So we get from 1 to 5.75 to 10.5 to 15.25 to 20. Then after this, we'll go to create an identity matrix. That's a very simple function. It's np.I and the dimensions that we want. 3 will give us a 3 cross 3 matrix, 4 will give us a 4 cross 4, and so on. To create an array with random numbers of uniform distribution, that means numbers which only have a value between 0 and 1, is done by this function called np.random.rand and the dimensions that we want. 3, 2 gives us 3 rows and 2 columns, and we can change this according to whatever we want. But this will always give us values which are between 0 and 1, as you can see here. Then to create an array with random integers, suppose we don't want decimal numbers and we want any random integer. Why constrict yourself to just 0 and 1? So to do that, we will use np.random.randint, where the brackets have 3 commands. One is the start value, one is the end value, and one is the size of the array. So for example, in this example, the size of the array is 5 and all the values are between 1 and 50. There's no value less than 1 and there's no value more than 50. So yeah, once we're done with this, let's look at all the attributes and methods of a Numpy array. So yeah, first of all, for that, we'll create an array like we did, np.arange 10, 100, 5. That basically, this is the start value, this is the end value, and 5 is the step value. So 10, 15, 20, 25, and so on. Now suppose we have created a one-dimensional array, but then we want to change this to a matrix. Suppose we have some need for it to be a matrix. So how would we do that? So to do that, we will use the reshape function. The reshape function basically squeezes, the reshape function will basically change a one-dimensional matrix to any dimension that we want. Here too, because I want to change this to a matrix. So, but the catch in this is that the rows and columns that you define, that you give to the reshape function, when multiplied, should be the number of values that you have in that array. For example, here we have 18 values. From 10 to 95, we have 18 values. So the rows and columns that I give here should always multiply to give 18. For example, 3 and 6, 9 and 2, and so on. Because suppose you give 5 and 5 or 5 and 4 as the values that you want to be the rows and columns. But then, so the matrix would have a total of 20 values for 5 and 4, but then you only have 18. So we cannot have 2 missing values in our matrix. So hence you would get an error accordingly. Then after this is done, we just go to basic functions again. One is arr1.max will give us the maximum value in that array, like we see 95. Then min will give us the minimum value 10. Argmax would give us the index where the maximum value is. For example, in this array, 95 is at the last position. If we start from 0, this will be the 17th position as we have 18 values here. So the 17th position has 95, and hence that position is the position where there is the maximum value, and that's what argmax gives us. And the same for argmin, as argmin is 10, the minimum value is 10, and it's at the place 0, the 0th position. Because when we use Python, the indexing starts from 0 and not 1. It goes from 0, 1, 2, and not 1, 2, 3, 4. So yeah, so therefore we have 0 here. Then the shape method just gives us the shape of the array. So like I said, AR1 just has 18 values back to back. So it's just a single dimension, 18. But the matrix that we made using reshape, that is a matrix with 3 rows and 6 columns. So that's 3 cross 6. That's the shape of it, 3 rows and 6 columns. Then after this, we'll go to finding the data type of the elements in the array. That's again a simple function, AR1.dType. So dType is basically all these values that we have in this array are all integers. So that's int 64. That's just the way for Python to show an integer. Then we go to indexing and slicing, which I'm pretty sure you would know a bit about beforehand. So yeah, suppose we want the value at the 4th position. That is, in actual terms, the 5th position of the array, because we are starting from 0. So 0, 1, 2, 3, 4, the 5th one. If we go back to the array, we can see that it's 0, 1, 2, 3, and 4. That's 30. So 30 is what we get here. Now, suppose we want the chain of values between the start and the end that we have defined. So here, you'd start, suppose I've written AR1 brackets 3 column 7. That will basically give us all the values between 3 and 7, including 3 and excluding 7. So that means the 3rd position, the 4th position, the 5th and the 6th position, and the values for them. So 25, 30, 35, and 40. Now suppose I want to change the values. I want to change the values to some value I want between 3 and 7. So to do that, I'll just write the same function again, AR1 brackets 3 colon 7, and equal to whatever value I want. Here I've written 50 because I want to change all of that to 50. So as you can see, 0, 1, 2, 3. So the 3rd position, the 4th position, the 5th and the 6th have all turned to 50, like we wanted. Now this is another function almost the same as that. And here we have not specified any value before and after the column. This will basically help us in converting all the values in the array to 100, A to Z. But since we still have a use for this array as we go on, so I'm not exactly run that here. I've just commented it out just to give us an idea, because otherwise we won't be able to carry out a lot of processes that we want after this. But suppose I want to just create a copy of this array. I don't exactly want to change my original array because I might have a need for it afterwards. But I also want these changes nonetheless. So to do that, I'll first make a copy of the array. This is just a name for it, is equal to AR1.copy. And now whatever I want to do, I'll do that on the copy, AR1 underscore copy bracket 12 column 16 is equal to 60. That will basically change the 12th, 13th, 14th, and 15th indices to 60, like we see here, 12, 13, 14, 15. And yeah, this we have just printed it out to show. And this is the original array. See, as you can see, this does not have 60s from the 12th to 15th indices. The processes have only happened at the copy, on the copy. They have one copy, not the actual array. Now we go to the 2D Numpy arrays, which are matrices, as we have seen. So let's just create an array. Now, indexing or indexing for this is a bit different than a one-dimensional array. The only difference is that here we have to specify both the row and the column of the value that we want. And again, as I've mentioned again and again, indexing starts from 0 and not 1. So here, if you're writing 1 and 2, that basically means the second row and the 3rd column, not the 1st and the 2nd. So the 2nd row is this, and the 3rd column is this, the 3rd column. So if we get both of that, we can see that the 2nd row and the 3rd column has 6 as the value. So we get 6 here. Now suppose I want a subpart of the matrix. I want to slice off one part of the matrix, any one part of the matrix. So there are two ways to do this. One is like not two ways, but then there are two different methods. Like it's like if you write a colon and then give a value next to it, that means this colon will take in all the rows before one or all the columns before one. For example, if I write colon 1, that only means that I'll be taking the 0th row, because here this is the first one, so this will be corresponding to the row. And since it's colon 1, it will only be taking the 0th row and not the first and second row, or not even the first row, even though there is a 1 here. But if I write a 1 before the column, that means I have to take all the rows or columns after 1, including 1. So here in this example, it's colon 1, comma 1 colon. So that means it's only the 0th row and the first and the second columns. Because when the colon comes afterwards, we include the value, and when the colon comes before, we exclude the value. So we get accordingly. This is the 0th row, as in the first row, like the first row of the matrix that has the index of 0. And these are the ending two columns, like we have mentioned here. So we get 2 and 3 as the sliced off matrix. And this is another example just showing the same thing. Now to perform conditional selection, for example, we want to check whether something is, we want to check a condition, so basically. If we want to, like suppose here, we want to check whether all the elements of the array are greater than 45 or not. So to do that, we'll first create another array called Boolean array, just for an example here, equal to array1 greater than 45. And now when we print that, we'll see that all the values which are not greater than 45 will return false and all the others will return true. Now to get the values where it's true, we can just either write array1 brackets and Boolean array, that will just basically give us all the values that are true, or we can directly write the command inside array1 as brackets AR1 bracket AR1 greater than 45, and that will also give us the same output. Now we go to arithmetic operations on arrays. Now arithmetic operations work element wise on Numpy arrays. Like for example, to do this, you need both the arrays to have similar dimensions. You cannot have different dimensions and expect them to be added or multiplied. So for example, first we go to addition. So since an array will of course have same dimensions as itself, so I've just added the array to itself so that we don't have any problem of different dimensions. So AR1 plus AR1 will basically be 20, 30, 40 because our original array was 10, 20, 30 and so on. Then AR1 multiplied by AR1 will also be element wise. It will be 10 into 10 plus 15 into 15 plus 20 into 20 and so on. Just that small change here is that this multiplication does not mean our matrix multiplication, where we want to check whether the columns of the first are equal to the rows of the second, and then when we multiply them, we get the matrix as an with dimensions, the remaining two dimensions. It's not a generic matrix multiplication. This is called element-wise matrix multiplication, where we need both the arrays to be of similar dimensions, and every single element gets multiplied to the same element in the other matrix, to the element at the same index in the other matrix. That's how written here. For matrices, the shape should match, otherwise we get an error. For example, I'll just show you what error we have. Suppose I make an array 3 cross 4 matrix. This is a 3 cross 4 matrix and this is a 4 cross 3 matrix. So now when we usually multiply matrices, this should be an ideal case. This will give us a 3 cross 3 matrix. But for how we usually multiply matrices. But then here, as I've shown you, we have to transpose AR of 4 first, so that it goes to a 3 cross 4 matrix, and then we have to multiply both of them. Only then we get an output. If we directly try to multiply them, we get an error. Could not be broadcast together because shapes do not match. And this dot t, by the way, is just the transpose function. You write dot t after a matrix and it transposes, it just interchanges the dimensions of the rows and the columns. Now to perform NumPy array universal functions, these are all just normal functions. SQRT will basically give the square root of all the values in the array. So since AR of 3 is 9876 and all, this will give 3, 2.82, 2.64 and so on. Exponential of AR3 will basically give e to the power of the value that we had at that index, and it will create a new array for the same. So this will be e raised to 3, e raised to 4 and all. And this plus 0, 3 that you see, plus 0, 1, that basically multiplied to the power of 10, like 8.1 into 10 raised to 3, 5.45 into 10 raised to 1, and so on. To find the maximum of the array, AR3.max, np.sign AR3 would just give the sign values for all the values. Log also would just give the log values for all the values at all the indices. Now we come to the point that I just discussed. Difference between dot product and multiplication of matrices. Now multiplies each value of one matrix to the corresponding value at the same position in the other matrix. Like I said just now, both the matrices should be of the similar shape, and every single value would be multiplied to the same one at the same index of the other matrix. That's multiply. So the asterisk that we used here is the multiply function and not the dot product function. The dot product function is our usual matrix multiplication, where we want the inner dimension of one should match the outer dimension of the other. The second dimension that you have is the inner dimension, and the first dimension that you have is the outer dimension. So both of these should be matching, otherwise we'll get an error in dot product, which is our actual matrix multiplication. So here, like for example, for np.multiply AR3, AR3, we get a nice value, and for dot, we need to use such matrices one of whose inner dimension is equal to the outer dimension of the others. So such as here, AR3 is 3 cross 4, 4 cross 3, and AR4 is 3 cross 4. So we get, AR3 is 4 cross 3 and AR4 is 3 cross 4. So we get, AR3 is a 3 cross 4 matrix and AR4 is a 4 cross 3 matrix. So we get 3 cross 4 matrix accordingly. Now we come to the Ravel function. The Ravel function basically helps us to flatten out a matrix. For example, you have an array of more than one dimension. So you want it to come to a single dimension because you might have any need for it. So because of why you have to convert it to a single dimension. But yeah, so to do that, we use the Ravel function, which will basically bring this down from 2 or 3 or whatever dimensions to 1. And reshape kind of does the same purpose, but then it will retain the number of dimensions that the array has. For example, here we have 12 values. This is 3 rows and 4 columns. So this is a 3 cross 4 matrix, and there are 12 values. So if you use Ravel on this, that will just give you an array of dimension 12, only one dimension. But if you use reshape 1, -1, it will give you a 12 cross 1 matrix. It won't be a 12. It won't be a single dimension. It will still be a matrix, but then it will flatten it out. One of the dimensions would be 1, but it would still be, as you can see, there are 2 brackets here, but only 1 here. Like how I had said, that would help us in determining the number of dimensions that we have. So that's basically the end of NumPy, and I'll be giving a small quiz now. You all should just scan this QR code and you will get the quiz accordingly. Just scan this, just a second. I'll start the quiz in exactly a minute. Just join everyone till then. So yeah, we'll start off. So basically it's a multiple choice quiz. You have 45 seconds for each question, and there are a total of 2 questions, just 2 questions. So yeah, 3, 2, 1, start.
I'm in the middle of this. You can join via YouTube. Hey. You can join on YouTube. I'm a princess.
Jumpy. Oh, do you want a sandwich?
Hmm?
Do you want a sandwich? Hello? Do you want or not?
Yeah, actually not really.
Huh?
Not really.
Not right now or not at all?
Not right now.
Huh? Not right now or not at all, Mono?
Not right now.
Okay. They're on the table.
So yeah, like judging from the number of correct answers, I'm guessing you have a fair idea of what Numpy is. So yeah, we'll just start off with pandas. So again, pandas is just another library. It's a tool to help us with all our data. It helps us organize our data into tables. Numpy use arrays, pandas will use tables.
She can't eat it.
So again, this is, like I said, not the entire pandas documentation. You can refer to the actual documentation to know everything about pandas, but this is all the fundamental topics that you would want in pandas to just get you going. So yeah, again, to install pandas, you will use exclamation pip install pandas. And since we have already downloaded it, it shows requirement already satisfied. So yeah, we'll start off with pandas series. What exactly are pandas series? Now a series is a one-dimensional labeled array that can hold any data type, integers, strings, floating point numbers, etc. But it will be an ordered array. It won't be an unordered array like an NumPy array. This will be an ordered array. For example, if I create a series, first of all, we need to import pandas as PD. Now this as PD will do the same function like as NP did for the NumPys. We can always just use PD as pandas. So pd.series will just change this list to an ordered array. 0, 1, 2, 3, 4 will be the indices are shown to us. That's a pandas series. Now comes the most important part of pandas, a data frame. That's a table. Now, for example, I made a dictionary. Now a dictionary is just you have keys which are basically the headlines of what information you want to put. For example, name is Alice, Bob, Charlie, David, Emily. Age will be 25, 32, 18, 47, 22, and country is whatever. So these are basically headings, and these are the data. So to change this to a table, we can use df is equal to df is just what we would like it to be called is equal to pd dot data frame and data. Now data is what this dictionary that we have made, and now we just print this. So now as you can see, we get a complete table with the headings, the names, another heading, the ages heading, and the countries. And we also have indices. So now this is a pandas data frame from a dictionary. This is a dictionary that we have made. Now, for example, we have an Excel file with cells and information and whatnot. Now, suppose we want to change that to a Pandas data frame. We want to bring that into this code and change this into a Pandas data frame. To do that, we'll use the read Excel function. So df is equal to pd dot read Excel and the name of the Excel sheet that you have, then print it accordingly. Now, I've commented this out because this is just a dummy document. We don't have this now, and this will just cause an error because I've not imported the. I don't exactly have a sheet like that. And the same for a CSV file, pd.read CSV data.csv. And again, we do not have a file like that because whatever we'll be doing today is from a link, and that will go on forward for that. So to make a Pandas data frame from a URL, a link, we'll first give it a name, then the link that we want. For example, this is a link that I'll be using today. I took it from GitHub. This basically gives us the charges, the amount of money a company takes from its different users for the medical insurance that they have. For example, it's a medical insurance company, and it's charging specific amounts to all the people who have taken its policies. So, and since this link is a .csv file, as you can see here, so hence we use again the read CSV function. So df is equal to pd.read CSV medical charges URL, and then print it out. And then this is what we get. This is the entire table: age, gender, body mass index, children, smoker, region, charges, etc. So now this table that we have, suppose I don't want all these rows. There are 1337. Like, to be honest, from 0 to 1337, it's 1338 rows. I don't want these much, suppose. So to just view some of the top rows, if I can get a fair idea from that, I'll just write df.head bracket 3. That will give us the first 3 rows of the entire table, of the entire data frame, to be more precise. That will be 0, 1, and 2, and all the information corresponding to the same. Now to view the bottom n rows, the last rows, to check whether there's no discrepancies in the information that we have, to just check whether everything is uniform. I get to just like, how should I say this? To just ensure that the start data and the end data are corresponding to each other. There's no random differences in them. To do that, we'll use df.tail and bracket 4. That will give us the last 4 rows of the table. Now to select rows and columns simultaneously. So to do that, we use the log function. The log is basically location. So df.log 3:7, comma, brackets, age, comma, BMI. So now age and BMI are the columns that we want. We include that in another smaller bracket inside the bigger bracket. And 3:7 is basically the rows that we want. But here, both the start and the end values are included. Nothing is excluded. So we get 3, 4, 5, 6, and 7, and the age and the column, the age and the BMI column. And ilog is used to select rows and columns by integer position. Suppose I'm too lazy to write age and BMI. I just want to write the number at which the column comes. So as we can see here, age is the 0th column, BMI is the second, the 0, 1, and second column. So I could just write 0 and 2 inside the brackets, and I'll get the same answer like I did. Now to check the data type of each column, pretty similar to Numpy, df.dtypes, that will give us the data types of all the columns. Now age is an integer, gender or sex, whatever we call it, that's a string. That's a string. String is also called an object. BMI is a float number because we can also have decimals. We can have someone with a BMI of 22.5 or 23.6. And by the way, BMI is body mass index. It basically is the weight to height ratio of someone to check whether they are underweight, overweight, or they fall in the perfect weight category. Now, children is again an integer. You cannot have decimals of children. It will only be 0, 1, 2, 3, and 4. Smoker is an object, string, yes, no. Both are words. Region is southeast, northeast, southwest, northwest, south, northwest. And that's also a string. Charges is float 64. You can have decimals of charges. You can basically have both integers and decimals of charges. So it will also be a float 64. Now checking the overview of your data set. For example, I just want to check how many values there are, how many of them are non-null. Now, what do I mean by non-null? Now, non-null is basically all the present values in the data set. There should be no missing values. A missing value is called a null value. Now there's a difference. For example, I'll just give you an example. Take children, for example. There are 1338 non-null values for it. But haven't you seen zeros in children? Someone can have 0 children. So why is it non-null? Many people can argue that 0 is a null value. But then that's exactly not the case. Non-null basically shows only the missing values in a data frame. It does not correspond to 0. So when someone tells us that they have 0 children, that we are gaining information from that. That can have a positive or negative impact on how much medical insurance they are charged. Null is only used when there is a blank there. There's no information pertaining to that. That's when, and since we have information for everything, it's all non-null. 1338 non-null values for all the columns because there's not a single missing data point in the entire data frame. And this is a D type, the data type that we already found out. We can directly use a shortcut df.info and we can get all of this together. And we also get all the memory that it takes and all those extra stuff. df.describe will basically give us all the mathematical operations on all the aggregation functions on the data, for example. And this will only, of course, be done on the numerical values. Now, you cannot take the mean of a string. That doesn't make sense. So this will only give us the mean, standard deviation, minimum, the 25% quantile, the 50% quantile, the 70% quantile, and the maximum one. Now, what is quantile? I'll go into that in some time. But yeah, so it basically gives us all these aggregation functions for age, BMI, children, and charges, all of which are numerical values. df.shape will basically give us the shape of the data frame or table, because in all practical senses, it's just a matrix. It can look very flashy and looks like a nice table, but in the end, it has rows, it has columns, it is a matrix. So it has 1338 rows, it has 7 columns. So our shape is 1338 cross 7. Now, to count the unique values in a column, for example, we have 2 answers for smoker, whether they smoke or not. It's no and yes. So for no, there are 1064 people who don't smoke, and yes, there are 274 people who smoke. So the number of unique values are 2. There are only 2 unique strings here, no and yes, different from each other. And 1064 and 274 are the number of times that unique value has repeated in the table. And then here we are checking the unique values in a column. This is the number of unique values. For example, here in this smoker function, it's df smoker will give us only 2 unique values, no and yes. But then for children, he has 6 unique values. Someone can have 0 children, 1 children, 3 children, 2 children, 5 or 4 children. And these are the numbers that are going to get repeated again and again in the entire table. Get my point? Then after this, to get the sum of a numerical field, it's just dot sum and parenthesis. This will basically give me the sum of all the charges everyone has been charged across all rows. So this will be the charges across all the 1338 rows added together. Then minimum will be the least someone has been charged. Maximum will be the most someone has been charged. Then df charges dot mean will give the mean of the charges. That means all the added charges that we have here upon 1338. That's what the average or mean does. Then median will give the value around which most of the values are centered. For example, here that we get 9382, that means a majority of the population have their medical insurance in and around 9382, not deviating a lot from it. So median is basically the value that someone has got the most. 9382 is around the maximum amount someone has, the maximum number of times someone has got a value around that. And now I'll come to quantile. Now, what exactly is a quantile? Suppose I say I want a quantile of 0.25. So that should return a value 25% of people are below which. For example, 0.25 is quantile is 4750, the charge. That means 25% of the populace is below 4740 in charges. They have been charged less than $4740. And 0.75 quantile gives us 16639. That means 75% of the populace is below $16639. They have been charged less than that. So 75 quantile is basically, it gives us the percentile of the people. it gives us how many people are above and below a specific percentile of quantile that we want. So 0.75 will basically give us 75% of the people are below this particular value. And that can apply to any table, any column that we want, numerical, of course. Here I just use charges. I can also do that for BMI, children. df.count will give us all the non-null values in the table. So age is 1338, sex is 1338, BMI is 1338, children is 1338, and so on. df charges.std will give us standard deviation. VAR will give us the variance. Now these are all mathematical formulas. You can just search them up to see what the actual functions are. Now to check each column in the data frame for missing values, the null values that I've been stressing on. So df.isNull basically gives us all the places where there is a null value. There is no value. The column is just empty, blank, missing. And since I've already said that our data set is complete, everything is there. There's not a single null value there. I could just, this function just shows false for every single cell. It just falls everywhere because we have every single value. Now, yeah, again, since there are no missing values, to check the number of missing values, we'll just sum it all up. So to see how many missing values we have, we'll use dot sum. So that will give us the number of missing values there are. And since, of course, there are not, so 0, 0, 0, not. But okay, so this is not giving us a right intuition about what's actually happening. So I'll just create a new data frame with null values. Now np.nan is basically used to create null values. Now nan is not a number. That means 1, 5, not a number. That means missing, nothing's here. 2, nothing's here. 10, nothing's here. 7, 11, 4, 8, and 12. So now suppose I want to replace these missing values with something. I don't want missing values. Missing values are not going to do anything good. So suppose I want to change these values with the mean of the other values in that column. For example, I want to replace this nan with a mean of 4, 2, and 1. That means 7 by 3. That's 2.66. So I'll just write df1, which is the name of our data frame, dot fill na bracket df1 dot mean, comma in place and false and true. Like what in place does exactly is, if I write this as true, for example, I'll just do that here. Let's see how it changes. We actually get the value here, 2.33, 6.67, and 11, because those are the averages. Now what in place is equal to true does is that it actually carries out that operation on our original data frame. So if I use in place true, that will change the values in the actual data frame. But if I use in place equal to false, it will just store the values and it will just, we know that we have done that on the data frame, but then that will not exactly be showcased here. For example, if I run this at false, I'll get nan here because this is our original df. But now afterwards, if I create some new variable and call this and then change it to in place true, I'll get those values accordingly. The in place is equal to false is just done because for the time being, we have to perform this, but then we don't want it to exactly change at this point because we may have a need for the unchanged data frame later on. Now, suppose I see I have a column which has missing data, so it's not exactly useful for me. It's a waste because if I am missing data, I'm not going to gain any information out of it. I want to drop that. I don't want that column. So I'll use df1 dot drop na axis 1. Now axis 1 is basically represents a column. Axis equal to 0 represents a row. Axis equal to 1 represents a column. I want to drop a column. So axis equal to 1 in place 2 because I want to do that to our original array, original data frame. And since it's in place 2, when I print this out, I get nothing. It's just empty because all 3 of our columns have missing values. So the software saw that all 3 of them have it. So, and since I've asked to drop all columns with missing values, it just erased the data frame entirely. Nothing. Now suppose I want to rename columns. I want to change the name of, like, children is too large. Let's just change it to kids. So I'll do df.rename columns equal to curly brackets children colon kids in place 2 because I want to change that in our actual data frame. So yeah, you can see the children, which we had children before, that's changed to kids. Now suppose I want to sort the data frame by a column. I'm not getting a lot of information seeing random money being charged by random people. So I want to see a trend. So I'll sort it out in ascending order. Suppose I want to sort it out in ascending or descending order. I want to sort it out based on the charges. So I want the person to be person who is charged the highest. I want to see why he has been charged so much. What's the reason? And then what's the trend? Who are the people who are being charged the highest? So to do that, I'll write ascending equal to false. That means descending equal to true, the same thing. And charges, because charges is a column by which we have to sort it. df.sort values charges ascending equal to false. So now that will give us all the information in descending order. So charges, this is the highest that we have, and this is the lowest that we have. And of course, if I change this to true, this will just 1121 will go up and 63,000 will come down. Now drop column of data frame. Now drop column of data frame is basically, if I want to drop one again, I don't have a need for that column. I just want to kick that out of my data frame. So I'll just use df.drop region axis equal to 1, which shows the column, int is equal to true, as I reiterated. It will do the function on an actual data frame. And as you can see, the region column is gone. Now, suppose I want to group the data frame by a column and aggregating values. I mean by that is I want to group the data by gender. And I want to see what is the mean of the charges for females and males separately. I want to segregate the data based on the column and aggregating some other column to show me what I want. So here I have sorted it out as females and males, and this is the mean of the charges that I have both for females and males separately. Now I can also do this for example, for smoker. For example, I'll just ask if the person smokes or not, and ask the mean of the charges for people who smoke and people who do not. Here I use gender. So group by sex dot agg, which is aggregate, and then parenthesis curly brackets charges colon mean. Mean is what we want to do here. I can write median, I can write STD, via whatever. Then adding a new column to the data frame. I want a new column. I don't want to look at age and kids again and again to see what's the reason. I just want both of them combined into another column so that I can directly see the column and determine what the age and kids do to the overall medical insurance. So I'll create a new column, df bracket age and kids equal to df age as types str. Now what does this mean? This basically means, suppose I have age as 20 and kids as 2. I don't write this. I don't write as type str and just add them both plus. So won't that just give me like that either it would give an error or it would just add both 19 plus 1. That doesn't make sense. It would give us 20. So why would I want 20 as an answer? That will not give me anything. I just want the string value of that. I don't want the integer. I want the string. I want 19 as a word, and then and as a word, and then kids as a word. The number 0 is treated as a word here, a string here, and I want to merge all these three strings together. So 19 and 0. Now this gives me good information about both the age and the kids. So if we don't write this as type str here, that's bound to give us some error or the other, because we want both of them to be the same data type and want them to be strings in this case. Now to combine data sets. For example, we have two data sets, like both of which have separate columns, but some columns are similar. So the first one has A, B, C, D, E, and the other one has B, C, D, E, F. So B, C, D, and E are common in both the data frames. So when I merge two data sets or combine two data sets on a key, now here I set the key as A, B, C, D, E. So wherever the key matches in both the data sets, for example, here in this example, it's A, B, C, D and B, D, E, F. So here both the data sets match at B and D. So it would create a new data set out of these two with only the values stored in that key. For example, df1 is this, df2 is this. Merge df is pd.merge df1 df2 on key. Now key is what we have defined here. On key basically means merge it based on what we have given, based on key, which is this. So it will give us d and d, which are common in both these data frames, and x value will be the first value that comes to b, and y value will be the second value that comes to b. So b is 2 and 5, d is 4 and 6, 4 and 6. So this will merge df1 and df2 on the key column, resulting in a new data frame, merge df, that contains all the rows from both data frames where the key value matches. That's what I said. And then that brings us again to the end of Pandas. And as I said, I have a small quiz waiting for you on that. So I want you to again scan this QR code. I'll again set a timer of 1 minute and I'll start it off. So yeah, I'll be starting off in 3, 2, 1, and so yeah, that just brings us to the end of my part. So I'll hand it over to my fellow coordinator to take it on from here. And yeah, if you have any doubts up till here, free to ask. And regarding the attendance, to all of those who have doubts about that, the QR to the attendance will be given in the chat shortly. So don't worry about it. And yeah, you're still open to ask any doubts if you had in Numpy and Pandas. And if you did not understand any question in the quiz and whatever. Just specify the first question of quiz 1, the Numpy ones, or the Pandas one. Okay, I'll just go through all the questions. Just give me a second. Just a small explanation for all. Yeah. I'll go step by step. So the first question was, how would you access the element at the third row and the second column of a 2D Numpy array? Answer is, of course, 3. Because as I said, the second 2 will represent the third row and 1 will represent the second row. I had reiterated this a lot of times. Then the second one was to calculate the mean. It's just a simple function, np.mean array. So Numpy is more or less easy. The Pandas, I'll just go once. I'm assuming a lot of people had some doubts in that. So yeah. So this was the first one of the Pandas. So yeah, how would you filter the data frame DF to show only the people who have body mass index of more than 20? So here it's just DF brackets. DF BMI shows the column which we want. This is a column that it's calling that column and then passing on a condition saying it should be greater than 20. Now, if I would explain it in easier words, is that it's just bringing in all the values from the BMI column and then imposing a condition on that I just want all the values that are greater than 20 in this, and then show that to me in the data frame. Again, so that's why we have a DF again outside that. So hence this answer is correct. The others have some syntax issues as it doesn't have apostrophe, it doesn't have apostrophes, it doesn't have brackets and all that. Here it's parentheses, it should be square brackets. Where it's not, there is nothing called where in this. There's nothing called filter in this. And yeah. Now the second question is aggregating data. Now, how would you group the data by the smoke up column and calculate the mean BMI value for each answer? Yes and no was the question. So yeah, someone had a doubt saying both 2 and 3 should be correct. Now there's only a minute difference between them. One is this underscore should not be there here. It's just a combined word grouped by, and there's no complete aggregate word in the syntax. It's just AGG, as I had shown in the example. So that's the only difference between 2 and 3. And other problems are that there is just an entire word issue here. And then there's a bracket issue here that should be curly brackets and not square brackets. Then again, here there are no curly brackets, and again, some random syntax mistake here. There are no brackets here after this. So that's why second is the correct. So I hope that tends to all the doubts anyone has, and that's the end of one.
Hello everyone, I am Devashri and I'll be taking this session. Let me introduce again. I am Devashri from Electrical Engineering Department of IT Madras, and now I'll be taking session on Matplotlib and data preprocessing. So let's get. So I'll be starting off with Matplotlib and then I'll be going on towards data pre-processing. So firstly, you guys need to understand that data pre-processing is what we're trying to achieve in today's session. So, but for data pre-processing, we need different tools to manipulate data, visualize them, understand them, interpret them. So we're learning about libraries like Numpy, Pandas, and Matplotlib in detail, right? So let's get started with Matplotlib. So, as students, I'm sure you all would agree with this fact that it's much easier to, interpret and comprehend a picture or a graph or a plot rather than, a page filled with numbers or text. Right. So this is what exactly Matplotlib helps you to achieve. So Matplotlib is a Python library here again. In Google Colab, you don't have to install the library. It is already installed and you have to, it's enough if you just import it. Right. So Matplotlib is a very powerful visualization tool. Okay. It will help you to create static and even animated visualization. Then it provides a wide variety of plotting options with, you know, uh, to different levels of customization again. Okay, so let's get started with it. So, but Matplotlib is a very vast library, and it might get confusing where to start. So, even before you, start to learn about it, you might get lost and might not know where to start it. So, this session exactly aims you to get started with the basics. Right. So first, we need to import the required library. So, you need to import pyplot from Matplotlib. So this command right here from matplotlib import pyplot as PLT. So if you have to use any function from this library, you have to mention matplotlib dot pyplot dot the function name. So instead of writing this entire sentence in again and again multiple times, you can just use PLT. And this statement as PLT makes our life simple so that you can just write PLT instead of matplotlib.py. Right. Now we import NumPy and Panda. Now, because you have an idea about NumPy and Panda, it'll be much easier for you to understand how to do this. Right. So first, let's load a few data sets and use it to plot the data using Matplotlib. So for that, firstly, I'm sure all of you would have got the resources from either WhatsApp group or other Microsoft Teams. So here, so you can actually run this collab notebook along with me for your convenience. Right. So to upload these files, so basically for the Google Notebook to read your file, you need to upload the files to the notebook and then it perform the read function. So to upload, go to this file option right now, and there'll be an option of upload to session storage, this one. And you can select whatever documents you want to upload from the device you're using, right? So upload whatever the required file here. Then these three CSV files and to an image which was shared. So I'll wait for some time. You can upload this and then you can follow along. Right, I'll wait for a minute. So yeah, now in this piece of code, we are reading the CSV file. So basically, these are Excel, these are tables in CSV format. So this piece of code reads those CSV files into this collab notebook right here. So the command for that goes like dfmean is equal to pd is part pd dot read CSV and the file name. Note that again, this statement would work only if this file is uploaded here from the device. Only then this would work. So make sure that you've uploaded the files over here from your device and then you run. Okay, so similarly, you read other data frames, the DF center and DF. So it's not very significant for you all to know what is exactly contained in these CSV files. You can open them check, but yeah, let's create a new data frame here from these three data. Right. Okay. So here you need to create df.merge. So you need to merge. So let's first merge these two data frames based on the common column they have. That is centerized. These two, if you look, these two CSV files will have a common column that is center ID. So you merge these two data frames on this column you have, right? So now you've created the data frame here. Now again, you merge this data frame created in this step and the data frame df root on this uh, common column that is present, that is mean. So if you df.f prints out the first five rows of the data frame, and you can check out this is it. So it combine after merging the all the data frames using these. This is the resulting data frame that we will be using to uh, manipulate and extract information and plot that. So from school, basic plots we would have learned. One of the first graphs, probably I think we would have learned this bar graph. So yeah, let's see how to make a bar graph. So before making a bar graph, for a bar graph, what do you need? We need two features to plot in the x-axis and the y-axis. But this table right here contains a lot of columns, which can be used as the two features required for the x and y axis. So let's create a table as to what you want to plot in the x-axis and the y-axis, and then plot. It will make our job much simpler. Okay. First, we will be creating a pivot table. Okay, so table is equal to pd.pivot table, and first of all, pivot table, I don't think you would have come across that till now. A pivot table is used for reshaping and summarizing the data of the data frame. It helps you to transform data and convert columns to rows and rows to columns by applying functions to the group data in a customizable. See, for example, in this will give you an example of that. So pivot table. Here, the data is equal to df. The data it is supposed to consider to create the table is df. That is the data frame we created right here. Index is equal to the category. So this table is indexed by the category. As you can see over here, category, there are categories in beverages, category so here you can see in the table with the various categories. So this will be used to index the table, and the values used will be number of orders. Right, there is a column for number of orders over here. So you'll be using the number of orders over here. But that is a catch. Here, you're using one more function called aggregate function is equal to NP or sign. So this will be the parameter for this pivot table function. So what does this do? As you can see in this table, for category beverages, for example, this row contains category as beverage, and this has these many orders. But there are several rows with the category beverages, and there are multiple orders. So what this uh, code does is it considers all those rows that has the category beverages, and it sums up all those number of orders. So the total number of orders of the category beverages is this. Similarly, it forms that for all the given categories, and this is the resulting table. So the next is to plot in a bar. This is a very standard syntax for any graph we're going to plot. So for bar plot will be plt.bar. The parameters here will be table.index and table number of orders. So you can see, I'll explain each of these. So this will be the piece of code for to plot the bar graph, and this will be the resulting. So let's understand each of these commands one by one. plt.bar, the parameters are table.index and table number of orders. So this creates a bar graph with the index of the table, that is the food item, the categories on the x-axis, and the number of orders on the y-axis. That is the quantity, the number of orders. So here you can see the quantity sold is from 0 to 3.5 into 10 to the power 7. Here E7 represents it is multiplied by a factor of 10 to the power. And the next command, plt.expect rotation is equal to 60. This is simply to rotate the x-axis label by 60 degrees. Instead of it being horizontal, it's rotated by 60 degrees for better readability. If it would overlap, it would have been untidy and unreadable. So hence you rotate it by 60 degrees for better readability. Next, there is plt.x label, y label. So x label sets the label for the x-axis. This is basically naming the x-axis. What does the x-axis represent? So here you set it to food item, and for y-axis you set into quantity source. Now you need to set the title of the graph, this plt.title, and here would be the most popular food over here, and it displays the title of the graph. Yeah. Now, okay, so here when you write this much of the code and not write plt.show, it will create the plot, but will not display it. It will be in the figure format. So when you do plt.show, it displays it in the notebook. Right? plt.show simply to display it. Okay, so this was a very simple example for bar graph. So now let's see pie chart. Okay. Oh, we use pie chart to understand the percentage of different categories, right? So from the given data frame, let's understand what is the percentage distribution of the different cuisines. Okay, there is a column for cuisine, and let's see what is the percentage share for different cuisines. So let's okay. So before plotting the pie plot, we'll first create, like in previous case, we created a table. Here we'll create a dictionary to help us plot easily. So here we're creating a dictionary, D cuisine. We are initiating an empty dictionary. And now, so this dictionary is to store the cuisine, which will be the index, and its orders, which will be its value. Right. Dictionaries are key value pairs, right? So the keys will be cuisines and values will be the total number of orders. So first, let's find the total number of orders, like the total number of orders for all the food items in all the cuisines. So there'll be df of number of orders dot sum. So that is in sum all the values in the column number of orders. Now let's find the ratio of orders per cuisine. So let's create a for loop for this. For I in range, df of cuisine dot n unique. So this code right here, df cuisine dot n unique. This returns a number that is the total number of unique cuisines that are there. So in this case, it would return 4, that is Indian, Thai, Continental, Italian. There are 4 unique cuisines, so this will return a number 4. So for I in range 4, basically this is what. Let's see what's inside the loop. Now here you're defining is equal to df cuisine dot unique of I. So df cuisine dot unique, this returns a list with all the unique cuisines present in the column cuisine. So when you index it, so this is for indexing. So when you index it using I, you're taking the ith element, of that list, and you're equating it to C. So C represents the cuisine, the ith cuisine, and that is C. So we have found C. That will become the key. Now let's find the value, that is the number of orders. So C order will be df of df cuisine equals C and this. Okay, so let's break this. So first, let's see what is this. So if this means you consider only those rows for of the data frame whose cuisine equals C. That is the cuisine that is being considered in this iteration. That is the I cuisine in this. Okay. So you consider only those rows, and then you go to the column of number of orders, and you sum up all those number of orders. So let me explain with an example. So for example, in this aggregation, C is Indian. So now this will consider all the rows for which the cuisine is Indian, and it will sum up the orders for all those rows for which the cuisine is Indian, and that's how we find the total number of orders for the Indian cuisine. Now, D cuisine C, uh, right? So D cuisine C. So here this is the dictionary, and you're indexing it with C. Here C, as I had mentioned, is the key. Right, the key. So you're indexing it with the key is equal. So you're assigning the value to the key C, that is to the key of the cuisine. So the value will be the total number of the number of orders for that cuisine divided by the total number of orders. That is the fractional share of that cuisine in the total number of orders. So now let's plot pie. Okay. So for the PLT.py, um, x into 100 for x in b cuisine dot value. So okay, so in plt.py, it takes in the first two parameters will be x and y. So the x here will be for the data. So x into 100, this x is for d cuisine dot value. So it will consider the values of the dictionary of the dictionary we created. It will multiply it into 100 because we need the percentage and not the fraction. Labels is and now you're assigning the labels. So labels is just to print this text right here, that is Indian, Thai, Italian, and continental. So labels will be X for X and D cuisine dot keys because the cuisine names represent the keys. This parameter here means auto PCT is equal to percentage 0.1f. This means it displays the value of the percentage share till one decimal place accurately. So if you convert this, for example, you do 0.01, it will display it. Then do till yeah. Okay, here again it's just one decimal place accurately. Right. So these are exact values. That means if this was the thing, it will represent the two decimal places. Now, plt.title is giving the title to the plot, that is cuisine share percentage, and plt.show will display the plot, similar to what we saw. This is Python. This was just the explanation of each of these parameters. Okay, okay. Now let's come to histogram. Okay, so using histogram, let's take the data problem. That is, let's inspect the price effect, like how the number of orders change with the price. So here we're using base price. So that the two prices given in the data, that is base price and checkout price. We'll use the base price here. Okay, so to plot the histogram, plt dot hist df of base price. So this will consider the data for which it has to plot the histogram. That is df of base and these parameters. Right? We will understand what these parameters are. And then you said the x and y label. So x label will be base price range, and y label will be distinct order. And you said the type that is inspecting price. So here and plt.show to display the price. So this is how it looks. Okay, so let's understand each of these parameters here. This is just to customize and to display, modify the features to display the price. So R width is equal to 0.9. This sets the relative width. So okay, so if I change this, we'll be able to visualize it better. Let's change it to 0.5. As you can see here, these bars are equally spaced, right? That is, the relative width of the bars is 0.5. That is, between any two data points right here, the relative width of these bars will be 0.5. So for example, if the value is 1, then they'll be touching each other, and this is how it will be. Next is alpha. Alpha sets the transparency level or the opacity. Alpha is equal to 0.8 in this case. So let me reduce it. Say 0.3. It becomes more transparent. And if I set it to 1, it becomes opaque. So this is to just set the transparency level. And now color equals to it sets the color of the. So you can change the color, say, yellow. This is how it would look. Okay, and bin. Next parameter, bin. It sets the total number of bars. For example, here, bins is equal to 20. So between the first data point here and the maximum X value here, there are 20 bars. For example, if we can change this to 10, so the number of bars would reduce to 10. This is how it is. And the edge color is self-explanatory. The color used for the edge of the bar. So let's change it. How to change it to red. So these are just features you can use to modify how your plot looks and the aesthetic features. Now let's come to scatter. So using scatter plot, this is the most common plot you would be using, I would say, for in the upcoming sessions and to understand various other concepts of MX. This would be the most common plot you would use. So first, let's take a problem statement and try to plot scatter. So let's understand how the operational area affects the number of orders. So in this context, operational area means to what radius range, distance radius range, the food is being delivered. So now, okay. So again, as we did previously, will create a table which will help us plot it better. So here we're creating a table, OP table, operation table, PV dot pivot table. So here the data it is considering is PS, the data frame is created. Index will be operational area. So here this table will be indexed by the operational area. Values will be the number of orders. So the values for these will be the number of orders. And the aggregate function here we'll be using is np dot. So again, as we saw previously, so for all the rows that contain operational areas equal to 0.9, it sums up the number of orders, and this is the resulting number of. That is what the aggregate function is equal to np dot sum. Now I've printed just the first 5 rows of the operation table to see how it is. Now let's plot the scatter. So we use pld.scatter op table dot index. Okay, so here the first two parameters would be x, what goes on the x-axis, and the second parameter would be what goes on the y-axis. So on the x-axis, op table dot index. That will be the operational area, which is the index as we have set. So this would be the operational area. The y value on the y-axis goes the number of orders. The number of orders that is 0 to 1 maximum as it is here into 10 to the power 7. And this parameter marker is equal to O. So you can change how you want to display these points. For example, marker, say you want to change it to something like triangle. So V does that. If you change it to S, S means it will become square. You can also change the color, like any color, valid color that's there in the documentation. But in general, if you remove this parameter right here, it will consider the default color, that is, so blue is the default color for all the blue. So now for every plot as we do, set the X label, Y label, the title, the operational area. Set the X label, the Y label will be the number of orders, and the title will be this operation area set number. So this is the figure that's created. You can also save this figure to your device by using this command plt.savefig. And this whatever you give inside is the name you want to give to that image. So when you run this, it would have stored that thing to your device, right? Static.cm. From here, if you download, it will get saved to your device. So this is how you can save the plot to your device locally. And plt.show display. So now let's go to the line graph. Line graph is very common, and we also know the applications of it, and we would have come across it many times. So let's learn along with line plot. Let's also learn a new concept here, that is subplot. What subplot? So before that, let's do a little analysis. So let's add a new column to the given data. That is revenue. Then let's add the column revenue. So df of revenue is equal to df dot apply lambda x x dot checkout price into x dot number of orders. Okay. Here, what this does is basically here lambda, this lambda x, as you can see, is a function. It is an anonymous function. You usually when we create functions, we define the function and then we call the function and create an instance of it and use it. But if we want to use it. But here in this case, lambda x is an anonymous function, and when you call the function right here, so the statement you write here, in the statement you also mention what job it is supposed to do. For example, here lambda x dot checkout price into x dot number of orders. Here you're creating revenue, creating a column revenue. For each of those rows, the value for that should be the checkout price into the number of orders, which will give you the revenue. Here, axis equals to 1 parameter denotes that you're adding the revenue as a column and as a column and not as a row. So axis equals 1 denotes that it is a column and not a row. Okay, so this is to add the revenue column. Now let's add another column, month column. There is already the week column in the data frame previously. So df of month will be df week dot apply x, where x floor divided by 4. Basically, this considers the quotient after x is divided by 4. Here, considering that we're making a small assumption that each month contains 28 days, but it's not necessary, but roughly we can use it over here. So here again, we're using the lambda function, as I mentioned. This is very convenient for manipulating data sets, pandas data sets, because you can use that to do whatever you want in a single line, in a very compact as this, instead of defining a function separately and calling it over here. So yeah, now let's create two lists to store the month and month-wise, to store month-wise revenue. So month, this list stores the number of months, and month order stores the orders for that corresponding month. Similarly, for week, we'll create the week list to store the number of, and week order store its correspond the number of orders in the corresponding month. So for this, to add values to this, we have initiated empty list here to fill in with values. Let's create a for loop. For I in range, integer max df of max. So this considers the maximum value of uh, maximum value contained in the column month. So for example, say there are 40 months. So it will consider this would be the number 40. I have have typecasted this into int because In case if it was a decimal value, it will automatically take care and to prevent any error. During code execution, I've casted this into int, and for I in range this. So it will iterate those many number of times, as many maximum the number of months, the maximum number. So month dot append I. So it will append I, that is the index, to the list month, and month order dot append df of df month equals I dot revenue dot. So this one, let's break it down. So this code right here means you consider only those rows whose month equals I. For example, in some iteration, I is equal to 3. So it will consider those months where month is equal to 3, consider only those rows, and it will sum up the revenue. This is the revenue column we had created. It will sum up the revenue values of that, and it will append it to the list month. Okay. So this is how creating a month list with values where the values are the index of the month. And here in month order, the values will be the number of orders in that particular. Similarly, for week and week order, as we saw, for I in range, int, max, df of week. Similarly, so instead of months, just use week. Use the same functionality. Okay. So now, subplots. Okay, let's come to subplots. So now we will compare the revenue of the company in every week as well as in every month. That is comparing the weekly revenue and the monthly revenue. There are two line plots drawn side by side. So when you want to plot any graphs to make a comparison, uh, and you want to display it side by side or one below the other, for that you use subplot. Okay? Now let's see the code. Subplot, subplot, plt.subplot function. It returns a figure and an axis object. Okay, so hence you're equating this to figure, comma, fig, comma, ax, because it returns two objects, that is figure and an axis object. In plt.subplot, number of rows equals 1, number of columns equals 2, and fig size is equal to 20, 5. So here, number of rows equals 1, number of columns equals 2. It so this is basically to determine how you want the subplots to look. How do you want to display the subplots? For example, I want to display the two subplots side by side this way. So that is like consider these plots as grid. So this is first rectangle and this is the second rectangle. So have one row and two columns. So hence here you write n rows is equals 1 and n columns equals 2. So there's one row and two columns. This is how you want to display the subplot. And figure size, you can change the figure size over here. 20, 5, you can change it to 25, 5. You're changing it. Now we'll manipulate the first and the second axis. So here, this is the first axis and this is the second axis. Okay, so axis 0. So when you're indexing this ax of 0, that means you're considering this plot. And when it is ax1, you're considering this. So usually in previous ones, we've done plt dot something. But here you'll be going to do ax of 0, ax1. That is to be referring to this or this. So ax of 0 dot plot week, week order over here. So it will, these two parameters are what goes on the x-axis and what goes on the y-axis. So here, what would go on the x-axis? So that is week, the number of weeks over here. And what goes on the y-axis is the week order, the orders received in that week. So you can see it's from 0 to 3 into 10 power 8. The value is. Okay, and then you set x label. One thing to notice here is in case of subplot, the syntax is a little different from what you use for normal plots. Here it's x label, y label. In this case, you'll have to use set x label, set y label. So set X label week. So here it will be week, here will be revenue, Y label will be revenue, and title will be weekly input. This is to find the weekly input. And similarly for the second axis. So you will index it by AX plot month, month order. So the number of months go on the x-axis and the orders, revenue in that month goes on y-axis. So set the x label month, y label is revenue, and title as month. Then you show plt.show to this show both. So this was supplement. So there are various graphs and plots that you can plot using Matplotlib. I've covered just a few basic ones, which you'd be using more commonly. Then many other things which you can actually explore and check it out on in the documentation, in the official documentation of Matplotlib website. So now let's also see another important that is reading images. Many times you have to read images from the image contained on your device and uh, use it somewhere else or do some analysis on it. So for that, let's see how do you read an image. So for that, first you import matplotlib.image as img. So image, you create this object img.imread patronus.png. So this will read the image. So this patronus.png is something I have it on my device and I've uploaded it over here. Okay, so this will be that, and plt.imshow image. This will display the image. For example, here you can also change scatter.png was the image I had created and I had saved the figure on the previous one. So let's run and check for that. So it should ideally be, yeah, it will ideally display that with the axis given. This is to see for the dimensions. Numbers and the x and y axis here to find the dimension of the given image. So we come to an end of Matplotlib. In Matplotlib, there is a lot to explore, and I've covered only the plots which will be using very commonly, and you can customize it to customize it very specific to your data sets and perform many customizations. So for that, you can check out the Matplotlib documentation on this website right here. So by this, we end this Matplotlib and I have a question for you. So this is a Slido question. So keep your phones ready to scan the QR and I'll be starting the poll in time. So scan the QR. I'll wait for 1 minute. Okay, so I'll start the poll. I'll be stopping the poll in exactly 1 minute. So please select your answer. Poll. So this is a very syntax-based question and more logic involved. But the right answer would be save FIG. this one right here and not save as we saw here in this case. They had done it. Right? Save FIG to save the figure. Not an issue. This is a syntax-based question. This will be ending the code. So now we'll move on to next topic. Okay, so before that, do you guys have any doubts? No doubt. I'll wait for 2 more minutes if you have any doubts and clear that, or else I'll move on to the next. Yes. In subplot, the figure represents all the plots. So when you do plt.show, it displays all the subplots you would have plotted. In subplots, you would have given parameters for number of rows and columns, right? So it will display all the plots that you have defined. So the difference between Matplotlib and Seaborn is just another library to again visualization library again. Seaborn you can is much more aesthetic than Matplotlib. You can the color options you have there and the design options there is more, but Matplotlib is surely if you're a beginner, Matplotlib is suggested to get started with. I'll move on to the next topic. That is data preprocessing. Data preprocessing. So before I get started with this topic, data preprocessing. First, let me give you an intuitive idea of the ML algorithms. So the general workflow will be data collection. That is, first you gather the data, and then data preprocessing. You clean and organize the data, and then training. You feed the data into the algorithms, and then for the model to learn the pattern. And then evaluation, you test the model on the unseen data and you evaluate its performance. So, and then based on its performance, you adjust the parameters of the model to improve its performance. And then deployment, which you use it, it's basically real life application. Deployment. Data pre-processing, as you can see here, is one of the most initial and very crucial. So, simple. Okay, so a very simple definition of data pre-processing would be that it is a data mining technique which converts the raw data that is collected manually or from different sources into a much cleaner information. Uh, in one sentence, it is used to organize, sort, and format the raw data. So now let's see what are the different steps for data pre-processing. First, we'll import the necessary libraries, Numpy and Pandas. We always do. Now we read the data. So this step right here, data collection. We read the data set. As we saw here, df is equal to pd.read csv. Iris missing data. So here again, as we would have mentioned, go to the file option and you should have uploaded this file right here from your device. Okay. So now this df.head displays the initial 5 rows of the data. So okay, let's see what is contained in the data. Sepal length, sepal width, petal length, and petal width, and species. So these 4 features right here, these features describe the flower. So based on this information, um, it determines which species the flower belongs to. There are 3 species of it. That is Iris centosa, Iris virginica, and here Iris versicolor. So these 3 are the species of the flower. So now you will so how an ML model you would train the ML model, you would give them these features as input, and you would expect it to predict the species based on the features. You would want the model to you don't understand the pattern, then predict the speech pattern. So let's in the raw data, see, this df.shape, this returns the size of the data frame, that is the number of rows and number of columns, rows comma columns. So in the raw data that we get, it might contain a lot of missing data, inconsistent data, outliers. Missing data are the ones for which you do not have the value. You do not know what the values are. The values are missing. Inconsistent data would be something like that would have inconsistent data and outlier. This would have occurred because of error in uh, measurement or because of some other data that would have hidden between somewhere. So we need our first step would be to find the missing data in these columns and then to fill in the missing data. Okay, so firstly, to find the number of missing values in each column, this function df.isNull. So this command, it finds the total number of missing values in each column. So in ID column, there are no missing values. In length column, there are 11 missing values and so on. Similarly, in species column, there are 12. So this is what we do. So now you know that in these columns, these many values are missing. And you need to fill in the values for that. To input it to an ML model to do. This is the entire point of data preprocessing. But how do you know what values to fill in? So that we'll first have to find the data type of each column. And this will help us to decide which methods to use to fill in the missing one. Okay, so for this, to find the data type of each of the columns, you will use df.dtype. So this will give you the data types for each of the columns: ID, subplots, subplots, length, petal width, species. Okay, so as you can see, ID is integer as expected, and these values are float. All the features values are float values, and for species, it is an object term. This term right here, object, is very important to understand for the upcoming concept right here, that is categorical length. So this means the data contained in species column is categorical. First of all, categorical data. Categorical data represents discrete values that belongs to a specific set of categories or groups. So, for example, let's see if we see the data, what is the data contained in the column species and understand. So first, we will check for categorical columns. The categorical columns, we go to df.select dtype to select those data types where the data type is object.column. That is, you select those columns where the data type is object. This is what command does, and you print the categorical columns. Here we find the only categorical column in our data frame species. Okay, so now let's perform label encoding on the categorical columns in the table. So in the column species, we have three categories, that is Sentosa, versicolor, and virginic. So when a model is training, instead of it'll take input as Sentosa, versicolor, and virginic. So instead of it learning from strings such as Iris Sentosa, Iris versicolor, Iris virginic, it would be better if they're numbers and it can capture patterns easily in this context. So hence, performing label encoding is important. We perform label encoding on the categorical columns in the data. So label encoding is simply assigning integer value to each of these categories. So in this case, it will assign 0 to Iris Sentosa, 1 to Iris versicolor, and 2 to virgin. If there were more categories, it will assign 3, 4, and this. Okay, so to form, let's import label encoder from sklearn.preprocessing. So this library right here contains various functions for performing pre-processing, which we'll be using extensively. So here we create an instance of label encoder. Now, you take the column df of species equal to label encoder of fit transform. You basically perform transform on that column, and you do label encoding for that column, df. So when you print the df, so this is what it is. initially, if you would have seen, it was Iris Sentosa, etc. And in this case, you can see it is 0 to these values. So it is performed label input. But if you observe, then it should assign only 3 values, that is 0, 1, or 2. But there is, because there are only 3 categories, but we can also see a 3 here. That's because it has also taken NaN as one more category and it has performed label encoding for that. Okay, so it has also encoded the NaN values to an integer, that is 3. We have to undo that. So simply, what do we do that? So for df species is equal to df dot species replace 3 with np.nan. For this column, you replace in this column you replace the value 3 with np.nan over here. And then when you print the data frame df.x, so this is how it looks. So it is again converted this to nan. Wherever there was 3, it would have converted it to nan. So now we have converted all our data to numbers. So initially this column had strings, Iris Sentosa, etc. The name of this. So now we've encoded that into a number. So now let's fill in the missing. Okay. So to fill in the missing values for the categorical columns, we perform mode imputation. Okay. So for categorical column, you might argue why we use mode imputation. How do we know? Can we just okay? So first, let me explain what mode imputation. It involves replacing the missing values with the most frequent value that appears in the respective column. Just example, there are 10 rows, and 5 rows contain the number 0, and 2 rows contain 1 and 2 are empty. So it would take the mode of all rows, that would be 0, because 0 occurs the most number of times, and it will fill the missing rows with the value 0. That is what is mode imputation. This method is very straightforward. It works well for categorical variables. You might also argue that how do we know we have to, like, how can you just fill in the missing values with mode? Don't we have to observe and understand and then? There might be errors. Surely it might not be right. But because you do not know what the actual values are, you impute it with mode, and then after performing training, you find the accuracy of what your model is, and then you determine if that was right or not. Otherwise, you come back, you do more analysis on this, and then you find different patterns, and then impute it with a different method. So, but mode imputation is the most straightforward method, and it works pretty well. Okay, so to find the mode, you would use mode value is equal to df species dot mode of 0. So here we've indexed it with 0. So this point right here, df species dot mode, it returns a list with the values in the order. For example, 0 occurs the most number of times, then will be 0, comma 1. So it will return a list with all the values occurring with its frequency in descending order. So this, when it is indexed with 0, it considers first element. That is the element that occurs the maximum number. So this would be the mode value. So df species dot fill na. So this fill na method would fill the rows which have null value with the mode value. Okay. And this enclave equal to, as we saw earlier, will make changes to the actual data set contained. So now let's fill, this was filling the values for categorical column. Pretty. Now let's fill in the values for numerical column. Now for numerical column, the most common method is filling it with mean or median value. Again, this is the tested method and it works pretty well. So if you have to decide whether you have to use mean or median, you can see, first method is that you have to try both and check for what you get maximum accuracy. That is one way, but usually the pattern goes like, if the data is symmetric, then you use mean. If it is not symmetric and it contains outliers, in that case you do not use mean, you use median, because if it contains outliers, the extreme data points will affect the mean. Right. The mean would not be the most appropriate thing you would want to use. So use median in that. So in this case, considered I'm filling it with mean values. I'm filling all the missing values with the mean value. We could have taken median as well. So in this case, let's just go with mean. So mean value, first of all, let's find the mean values for each of these columns. So df of these columns. So I've put all these columns in the list. That means it will find the mean of all these columns. If you print mean values, it will print the mean values for all these columns. Okay, now data frame df dot fill any of mean values. That is, it will fill the missing values of the data frame with the mean values we have found for these 4 columns only. Okay, so this is the data right here. So now let's find check if we have filled in all the missing values. Initially, we have seen there were missing values in each of these columns. So now, when after using this command again, df dot is null dot sum. You see, we have filled in all the missing values, and there are no missing values. Okay. So next, let's come to feature scaling. So to understand what feature scaling is, see, first I'll explain what we've done exactly, and then I'll explain the intuitive idea and why should we perform feature scaling. Then you'd understand better. So first, let's find minimum and maximum values of the each column. So for that, it go minimum values of the df.min. It finds it for each column. This is to just print minimum and maximum values for each column. Oh, this one. So as you can see, minimum values for each of these columns are this 1, 4.4, 2, 1.0, 2.1. And similarly, maximum values are. So now let's in feature scaling. What do? Is we the range. Okay, so the range for a particular column is from the minimum value to the maximum value. For example, say sepal length is 4.4 to 7.9. In feature scaling, what do? We're using MinMax scaling formula. This is one of the feature scaling techniques. So using MinMax scaler, you squish the range from whatever is there uh, between 0 and 1. So after this is to perform feature scaling, this piece of code right here. After performing that, again, if you print out the minimum and maximum, you would see the minimum values is 0 for all this, and the maximum value is 1 for these 4 columns. Focus on just these 4 numerical columns for now. Okay. So what you're basically doing is switching the range from whatever it is to between 0 and 1. Okay, to do that, what do? So we import the MinMax scaler. It is already present in the SK learn.preprocessing library. So now let's specify the columns for MinMax scale. So these are these 4 numerical columns: petal length, petal width, sepal width, and sepal. Okay, so now you initialize the MinMax scaler. That is scalar is equal to this MinMax scaler, and now you fit the scaler on these specified columns, and you transform them. So df columns to scale, only consider the data frame with those columns, these columns, and then you fit transform them. Scalar dot fit transform, that is perform the min-max scaling on these columns. So after performing max scaling, if you print out the minimum maximum values, it gives this as the output. Okay. So why do we do feature scaling? So now that you understood what feature scaling is, why do we do feature scaling? So, for example, in this data set, the minimum, the range doesn't vary a lot. So these 4, for example, from 4.4 to 7.9 over here. In the other, it's 1 to 6.9. These aren't, the ranges aren't very different from each other. But for example, there was some data set in which you had 2 columns, say age. Age would range between 1 to 100. And there was say other column, let's say salary. Salary would range from say 100 to million, right? So in that case, the range for age column and the range for salary column would be very different. And when you're passing this to ML model, it will not uh, learn uniformly from these two features. So the features with the large numeric ranges, will dominate over the features with small ranges. That is, in this case, the the feature that is salary would dominate over the feature age, and which is not desirable, and this will lead to the model to give more weights to the features with more numeric range, size range. So this is not desirable, and to perform feature scaling. MinMax scaler is one of the scaling techniques. Another scaling technique is normalization. In normalization, here what you've done, here we've squished everything between 0 and 1. In normalization, what you do, you set the mean to 0, the mean of all the data to 0, and the variance to 1. So that is normalization. These are the two most commonly used feature scaling. So now after we have performed all that, we have filled in with missing values, so performed feature scaling. Now we let our data into X and Y, that is the features and the target variable. Okay, so yeah, before we split, let's check if we have any missing values, and if we have, let's recheck the size of the data set to check if we have lost any rows or columns during all this modification. So df dot is null dot none. So there are no missing values, and df dot shape, it is the same as previous, that is 150, so to divide it, split it into x and y, so df of x is equal to df dot drop species. In this case, the feature column will be the species column, so that will be df of y, and df of x will be remaining data frame, that is the data frame after dropping the species column. Your axis 1 represents you're dropping the species column, the entire column. So now this splits it into X and Y. So now we perform the trained test split on X and Y. So from sklearn, there is a train test split inbuilt library again in sklearn.model selection, and we import that and then use it. So so this train test split function returns 4 values, that is x train, x test, y train, and y. So the parameters are x, df of x, that is the feature data set, df of y, that is the target variable data set, and the test. And the test size we would use, this test size determines what is, for example, this here test size is 0.2. That means it's the train set would contain 80% of the data, and the test set would contain 20%. Okay, so this returns 4 things, that is x train, x test, y train, and y. And now our data set is pre-processed and ready to be trained. So giving you an idea what happens after this. So now you train your ML model using X train and Y train. You input X train, also you input Y train. So basically you can think of it like a question and an answer. X train is the question, Y train is the answer. So it will find patterns from that X train and Y train, and it will learn from these patterns. And now uh, you 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 input X test to perform evaluation. You input X test, and it will predict values, and then that is Y predicting. It will predict that. It will compare that with Y test, and that is how accuracy is defined. So how close are the Y predicted values to Y test values? So based on this, you can evaluation is performed, and you can change the parameters of your ML model and improve. You can help improve them. So this we come to an end of this. We are done with this right now. So till in these two sessions, we have covered all the basic tools that you would require to go about, and all the necessary tools that we require for ML. Now, from upcoming sessions, we will delve deeper into the concepts of ML, the math behind it, and what the algorithms are. So, yeah, any doubts? till now? Do you guys have any questions? Yeah, aggregate function is used. Okay, so in aggregate function will be a parameter of the pivot table. So when that aggregate function is used, so for example, here we had used sum as the aggregate function. So it will consider all those rows whose category is the defined category, and it will perform that function. That is the sum of all the orders of the category mentioned. So that the function aggregate function would basically define what function you want to perform on the rows that contain that particular category or whatever you define. What X test? What are we comparing X test to check if it is correctly trained? So now, after your ML has model has learned, now you will give X test as the input, and now it will predict some value. So, but you already know Y test. That is the corresponding Y values for the X test data that you have provided from the data you have. So you will compare that Y test values with Y predicted, and that's how you can check if it is correctly trained, and you will henceforth find the accuracy. Okay. Regarding attendance issues, the attendance link was sent before and it won't be sent again. So don't spam in the group on the chat regarding that. Okay, so I guess you have a lot of doubts regarding X test and Y test. So this wasn't really required to be covered in this session. In the upcoming sessions, you will see how to train a model, how do you perform training, and how do you calculate the accuracy, and how do you improve that model. So when that is done, you'll understand it much better. So for now, you don't really have to worry about it. Yes, the class is over. If you have any doubts, you can ask, or we'll just start. Then I'll wrap up the session. Hope you all understood something and learned something new. And do brush up all these concepts. Give assignments a shot, and also on the Insta polls, attend the quizzes on that, so that you will brush up the concept and be ready for the upcoming.